let's try an example of binary subtraction. The question is 16.5 in decimal minus 4.25 in decimal, and this you have to subtract using binary subtraction. So first of all, you have to convert 16.5 to binary, then 4.25 to binary. Then find the 2's complement of 4.25 minus 4.25 and add these two. Okay. So binary subtraction is basically write the (16.5) is (16) we know is 1, 16, and 0.5 is 1, 0.1, and 4.25, that is 4.25, positive 4.25. You'll first write the positive number, then take the 1's complement, add 1 to the 1's complement, and add the 2's complement form which you get after adding 1's complement and 1 to the first number. So this is 10000.1. So when you take this as, this is a subtraction, so 16.5 is taken as positive 16.5. So you have to add the sign bit to the left, and 4.25, we know 4 is 100 and 0.25 is 0.01. Okay, so you need to add the zeros, that is both these numbers we will make it to the same number of bits. Okay, so in the first case 16.5, you have extra bits to the left, so you'll add zeros to the left, and here you have an extra bit to the right, so here we will add a 0. Okay, so that both the numbers have the same number of bits. Now what we know is these two are positive numbers. These two are positive numbers, and we've just written the binary of these two positive numbers. Now the question is 16.5, which is this itself, minus 4.25. So what do we need? We need the 2's complement of minus 4.25, the binary equivalent of minus 4.25, 2's complement of. So for that, what do? You first write plus 4.25 in binary, then find the 1's complement of minus 4.25, that is you complement every bit, yes, then you have to find the 2's complement of minus 4.25, that is 1's complement plus 1. So that will be 1, 1, 0.1, 1, 0, 1, 1 and 1. So now we have 2's complement of minus 4.25 and 16.5. These two you will add. So for that, (16.5) is 0, 1, 0, 0, 0, 0, 0.10. Same thing I just copied, and 2's complement of this. So 1, 1, 1, 0, 1, 1.11. Right? So these two numbers I just copied there. Right? This is minus 4.25. And we'll just add these two numbers. Add why are we adding? Because this is minus 4.25. So it is 16.5 plus minus 4.25. Minus 4.25, how are you expressing? Using the 2's complement method. Now when you add, 0 plus 1 is 1, 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. So 1, 1, 0, carry 1, 0, and you get a carry which you will discard. Okay, since this is your sign bit, these are your sign bits. 0 is the sign bit of 16.5 because that is a positive number, and 1 is the sign bit of minus 4.25 because that is a negative number. So the answer sign bit is this one. This is the carry, extra bit, so you'll discard that. So this is your sign bit. So since the sign bit is 0, it is a positive number. Then just see what is the answer. So what is the answer? Since this is a positive number, the answer is same as whatever is given. So 0, 1, 1, 0, 0. That is 12. 0.01 is 25 to the base 10. So 16.5 minus 4.25 is 12.25, and the answer is correct. So here what you should know is, if the answer is positive, that is the sign bit of the answer of a subtraction is positive, then just find out the magnitude. This is the magnitude. Just write it down and that will be correct. Now suppose the sign bit is negative. That is, sign bit is 1. That is, the answer is negative. So if the answer is negative, which we will know by seeing the sign bit, which will be 1, then the answer will be in the 2's complement form if you are following the 2's complement method to find the difference. So we'll take an example of that. We'll just reverse this. That is, we'll just reverse this. The question was 4.25 minus 16.5, both to the base 10. So again 4.25, here 4.25 is positive, so that will be 100.01, and 16.5 plus 16.5 will be 16 will be 0.5. So by appending the zeros, that is, this is the largest number of the two, so we'll be putting a sign bit here and we'll just put zeros to fill the vacant places. Here we have another bit, so 0. Okay, just by adding those zeros, that is the whole number part, To the left, if you add zeros, the value doesn't change, and to the fraction part, if you add zeros to the right, then value doesn't change. So adding those zeros will just make work easy. It doesn't change the value, right? So 16.5 is this. We need to find minus 16.5. Minus 16.5 will be, take the ones complement of minus 16.5. Minus 16.5 ones complement we'll get by reversing each bit, or complementing each bit. So zeros will change to 1 and ones will change to zeros. And then we'll find the 2's complement of minus 16.5 by adding 1 to this. 1 plus 1 is 0, carry 1. Right? So we will be adding this to this. Right? So I'll just rub this. Okay. So it is 1 0 1 1 1 1.10. Correct? So this is minus 16.5. So we'll just add these two. 1 plus 0 is 1. Here we have a 1. 1 1 0. Carry 1. 0. Carry 1. 1 and 1. So if you notice here, this is 1. This is your sign bit. This is your sign bit, and sign bit is 1 means sign is negative. So sign is negative means this particular thing is in the 2's complement form, because we are using the 2's complement method, and in the 2's complement method all the negative numbers will be in the 2's complement form. So this is, you can't just take this as a binary number and find the value, that is convert it to decimal and see whether the answer is correct or not, since this is in the 2's complement form, not in the binary form. In the earlier case, since that was a positive number, that was in the binary form. Or you can say that the 2's complement form of a positive number is the binary form itself with a sign bit, which is 0. Okay, so both are the same, so that doesn't make a difference. But in this case, it's in the 2's complement form. So what do? To check whether the answer is correct or not, we'll find the 2's complement of this, and that is only to check whether the answer is correct. This is the answer. This is the answer. We'll check whether the answer is correct or not by again finding the 2's complement of this particular number. So this is minus of 0, 1, 1, 0, 0. I'm taking the 1's complement, 0, 0. And to find the, this is 1's plus 1. That will be 1, 0, 0, 0, 1, 1, 0 with a negative sign. So what is the answer? This is minus 12.25, which is the correct answer. Okay. So just understand these things. That is, if the answer is of the difference, when you're taking the difference of two numbers in binary, if the difference is positive, how do you understand that the difference is positive? Because the sign bit is 0, and it is negative if the sign bit is 1. So if the sign bit is 0, the value is positive. The answer is, or you can check whether the answer is correct or not by seeing that answer itself, because that will be the actual binary value. But if the sign bit is 1, then the answer is negative, and in 2's complement method, if the answer is negative, then that is in the 2's complement form. So you have to check whether the answer is correct or not by again finding the 2's complement. Right? So how do you say that the 2's complement of a, we'll just take an example, that is say minus 2 to the base 10. Okay, so minus 2 will be, how do you find minus 2? We'll first write plus 2 with a sign bit. That is 2 is 1 0. So sign bit is 0. 1's complement of plus 2 is 1 0 1, and 2's complement is this plus 1. That is 0 carry 1 1 1. So this is the 2's complement form of minus 2. Okay, so if the answer is say minus 2, then it will be like this. So you can't know whether the answer is correct or not, because you don't know the 2's complement of every number, every negative number. Okay, so if this is the 2's complement, we need to know that this is 2, and the in zeros and ones, the only way you know how 2 is represented is as 0 1 0 or just 1 0. Okay, so we need to get back to here. So how do you do this? You are going to find the 2's complement of this again. So how do you do that? 1 1 0, take the ones, that is 0 0 1, and take the 2's, that is add 1. So that is 0 carry 1. So if you take the 2's complement of a negative number, you get the positive value of that, or magnitude of that particular number. So this is the actual answer. But to know what is the value in binary, you'll take the 2's complement again, you'll reach at this particular value. So this is only the checking part. The actual answer is this. Okay. So that is about subtraction of binary numbers. 1, say 1 1 0 0 divided by, say 1 0. So that will be 1 1 0, 1 minus this will be 1 0, that will be 1 0 0. So we'll have to write that 0 there. So this is 12 divided by 2, and the answer is 6, and remainder 0. So answer is checked. So that is binary division. Binary division. Here we have taken an example 1 0 0 1 1 divided by 1 1. Now what is this actually? 1 0 0 1 1. So this is 1 2 4 8 16. So 16 plus 3, this is actually 19. And what we are doing is 19 divided by 3. Okay. So here this is 1 1. So if you take the first two bits, it is 1 0. So actually if we are taking just these two bits and these two bits, 1 0 is less than 1 1, right? Like in normal division, normal decimal division you do. If this is less, then this is 1 1, right? And you can write the quotient as only 1 or 0, right? So if you write 1 1 here, you can't write 1 1 here because this is a smaller number. So what you normally do is you'll be taking one more bit, right? So if you write 1 here, 1 times 1 1 will be like this, like in normal division. So 0 minus 1, 0 minus 1 you can't do, so you'll have to borrow 1. So when you borrow 1, this becomes 0. So when you borrow 1, this becomes 1 0 minus 1 will be 1. And here, since you have borrowed 1, you have only 0 here, right? So, or you can see that this is 1 0 0, which is 4, and 4 minus 3 is 1. So here you have only 1, so we'll take another 1 down. So again 1, so that will be 1 1. Here you will have 0. You'll take this. So here we've taken this 1 down, and when we take this 1 down, this is lesser than this, so it won't go. So you'll put a 0 here. And your answer is 110, which is 6 to the base 10. And your remainder, this is your quotient, and your remainder is 1 to the base 10. When 19 is divided by 3, you get 6, 18, 1. So answer is correct. Yes.